Alright, hello guys. Today we're going to be doing the Algebra 2 Regents from August of 2025. Alright, so with all the math regions, you're going to start off with part 1, where it's all multiple choice. It's 24 questions and 4 choice, and my tip is to never leave any of the question blank. You won't lose points for not getting a question correct, but you will lose points if you have no answers. Alright, what is the 7th term of the sequence? So over here we're gonna see what type of sequence this is. Is it an arithmetic, like you're adding, or is it geometric where you're like multiplying? So in this case, this is geometric. I'm multiplying by -3, so my ratio is gonna be -3. And then for this one, I think it would be helpful if we can define this if we're going to define it explicitly, not the recursive formula. And just remember, geometric sequences, we just have basically an exponential function. So we have -2 times, no, not -2. Let me go down. The formula is given to you, I believe. So it's right over here, geometric sequence. So let me copy this up here for you guys. Right here. So we have a sub n is equal to the first term times r to the n minus 1. So that means a sub n for our question is that -2 times the ratio, which is -3 to the n minus 1. And we wanted to find out what a sub 7 is. So that means it's -2 to the -3. -2 times -3 to the 7th minus 1. And I would just plug into the calculator because it appears that these are quite large numbers. -2, -3, 7 minus 1, and I get -1458. So the answer is choice 1. Okay, given that x is not equal to 0, where m of x is equal to 12 times x to the power of 8a, and p of x is equal to 3 times x to the power of 2a, the expression m of x over p of x is equivalent to. So this over here, we just have m of x, which is 12x to the 8a over 3x to the 2a. So this part's easy. The first part, this just simplifies to 4 because that just divides out. Now we have x, and now we have the second part. We have x to the 8a and x to the 2a. So over here, since they have the same base, and when we're dividing the exponents with like the same base, we just subtract the exponents. So this would be x to the 8a minus 2a, which is 6a. So the answer is choice 2. Okay, what is the inverse of f of x is equal to 2x plus 6? So first thing I'm going to do is I'm going to write this as, I'm going to change f of x to y. So y equals 2x plus 6. And then now to do the inverse, I'm just going to switch my x and the y. That's quite literally what the inverse is about. We're just kind of like flipping it. So x is equal to 2y plus 6. And then I'm basically isolating for y. So x minus 6 is equal to 2y. And if I divide everything by 2, I have 1/2 x minus 3 is equal to y. So that means my inverse, f to the -1 of x is equal to 1/2 x minus 3. So the answer is choice 3. Okay, the expression cube root of 16x to the power of 6 is equivalent to, so this, we can always break it up. This becomes cube root of 16 times the cube root of x to the power of 3. So if we look at the second one, this is just going to be, this is x to the power of 6. So this is the same thing as x to the power of 6 over 3, which is equal to x squared. How I remember it is that it's, so like when we have the square root of x, so square root of x, there's an invisible 2 in front, that's equal to x to 1/2. So I know that my index, the root, goes on the bottom, and whatever's inside goes on top. That's how I remembered it. Okay, now there's not really a lot more tricky here, but like the tricky part is the cube root of 16. So 16, I can separate that into 8 times 2. The cube root of 8 is 2, because 2 times 2 times 2 is equal to 8. All right, remember, this is cube root, not the square root. So then this is 2 times cube root of 2 times x squared. So the answer is choice 3. All right, Mary would like to determine if there's an association between a student's height and their shoe size. She measures the height and shoe size of every 10th person entering her school. This is an example of. So in this case, we can eliminate a control experiment. It's because Mary, she's doing like, she's just kind of like collecting data. A control experiment, we will have to manipulate a variable. And that's like an experiment. So if you're taking like like higher level like sciences, when you learn about like procedures of experiment, you know that in order for an experiment to be valid, you are controlling a variable. So in biology, you might have like a control experiment where you are manipulating the temperature and trying to see if there's a cause and effect relationship. In this case, she's not really manipulating anything because Mary is just collecting data. And is it a simulation? Similar logic is not a simulation because she's not like simulating anything, she's not manipulating anything, so not a simulation. Now, is it a sentence or an observational study? The answer is observational study. So for an observational study, you're just kind of like the word observational, you're just looking at it, you're not manipulating anything, you're just collecting data like as it is, like kind of like the person, the researcher is not interfering with what's happening. And then the census, I think a lot of us know what census is. It's like when you collect like a large information, like usually about like the population. So census, the U.S. conducts the census every 10 years, collects like demographics about people, and then that helps with like redistricting and stuff. So that's not really the case over here. The answer is choice 2. All right. For all values for which the expressions are divine, which expression cannot be rewritten as x minus 6 times x plus 2? Okay, this one I don't really like because it's you kind of have to test through every answer choice. So let's look at number 1. So we have let's choice 1. So we have x plus 2 times x squared minus 2x minus 24 all over x plus 4. So what I'm going to do is I'm actually going to factor the trinomial. So x plus 2, that remains the same. And in order to factor the trinomial, I like to think what multiply to negative 24 and add up to negative 2. And I'm thinking of 4 and 6. And one of them has to be negative because they multiply to a negative number. And it's negative 2. So that means like the quote-unquote, like the bigger one, it has to be negative. So I get x plus 4 times x minus 6. And then the denominator remains, and you can see that x minus 4 is a factor in both the numerator and the denominator, so we can cancel them out. So we just get x plus 2 times x plus 2 times x minus 6, and that is equivalent, so not 1. All right, 2, we have this over here, minus 6. Okay, this one's a little bit easier to factor. We just have to factor out the greatest common factor between the two terms. So this is a term and this is another term. The greatest common factor is x plus 2, so I'm going to factor that out. X plus 2, and what am I left with the first term? I'm left with the x. What am I left with for the second term? Minus 6. So that's how you factor by greatest common factor. And you'll see that this is indeed matching with what the question is giving us, so not 2. All right, let's go through answer choice 3. So we have this over here. This is very similar to answer choice 1. So it seems like we have to factor out the trinomial in the numerator. So we have to think about two numbers that multiply to negative 12 and two numbers that add up to negative 4. So this is known as the AC method, and it's kind of like the easiest way to factor when we have a trinomial and there's nothing in front of the x squared. It's like a 1 in front of the x squared. But when there is a number in front of the x squared, then I would recommend factoring by grouping. But then there are also like quicker like mental shortcuts that you can take other than that. Okay. Okay, two numbers that multiply to negative 12 and add up to negative 4. I'm thinking of 2 and 6, and since it's multiplied to a negative number, one of them has to be negative, and since it adds up to a negative number, then kind of like the bigger number has to be negative, so it's minus 6. So I get x minus 2 times x plus 2 times x minus 6 all over x minus 6. And you should see now that we have a common factor of x minus 6 in both the numerator and denominator, so we can cancel that out. And this becomes x minus 2 times x plus 2. And that does not match with whatever's given in the problem. So the answer is choice 3. And answer choice 4, we can still verify that. What I would do for this one is I would maybe I would for sure expand number 4 because we can't factor out as it is. There's no greatest common factor. So let me expand out that first. So it's x squared plus 4x. So the 4x minus 2x, so that's plus 2x. And then 4 times negative 2, that is negative 8. And then minus 2 times 3x, that's 6x. And then minus 4. And then that's equal to 2x minus 4x minus 4. Is that correct? No, minus 12. Okay, and then in this case, I guess we can factor that out. So multiply to negative 12 and add to negative 4. And I'm thinking of 2 and 6. And 6 takes the negative, so this is equal to x plus 2 times x minus 6. And that is indeed equivalent to whatever's given to us in the question. All right. Number 7, the number of hours in the lifespan of a certain brand of light bulb is normally distributed. So we have the key phrase there with a mean of 2,387 hours and a standard deviation of 238 hours. To the nearest tenth of a percent, what percent of light bulbs have a lifespan greater than 2750? All right. For this one, we're going to use a function on the calculator. So what it does basically is that, so we have this normal curve over here. This is a normal bell curve. And then we're using it so that we're kind of like, it's harder to visualize, but basically we want to kind of like find out what this area is greater than some sort of like lower bound. So the function on the calculator is known as normal CDF. And I have a very not official calculator here. The official calculator, the online calculator from TI, it doesn't work on the iPad, which is really unfortunate. So we're just gonna use this here. All right. We're gonna go to stat, and then you have is under no. Let me look for it. I forgot where it. I kind of forgot where it is. No. It's wait, hold on. Okay, it's second, and then you press where it says var. Above it says distribute. So this will be like distribution, and then you go down to 2, and then you get normal CDF. If you have the new calculator, you should get like kind of like a step that guides you through it. So for the lower bound, we do have a lower bound. So it says what percentage of light bulbs have a lifespan greater than 2750. So that's gonna be my lower bound. And then my upper bound, for this one, I'm just going to enter like a really, really big number. Because, you calculator, you can't really type in infinity, but we're just going to put a really big number. Okay, mu, that's going to be the mean. So be able to recognize that symbol. So it's 2387. And then sigma over here, that's going to be your standard deviation. That's 3238. And then you can paste. And then yeah, it calculates for you. So that right now is a decimal, and in order to convert it to a percent, you multiply it by 100, and for that you would get choice 1. Okay, oh, I just lost my calculator. Oh, I did not lose my calculator. Okay, all right, I'm scared that I will lose my calculator. Okay, all right. For this one, you would do like normal CDF is 2750, and then some really big number, 9999, and then we have the, I think it was the mean, and then we have the standard deviation. So that's the order that you plug it in. Be able to recognize the symbol. So mu, that's going to be your mean, and then sigma is the standard deviation. All right, the solution set to the equation is, so for this one, what you can, of course, do is just graph it. So, like, this would be, like, your y1, and then this would be, like, your y2, and then you see where they intersect. But we're going to do it algebraically. So, by looking at, like, the restriction, since we have a bunch of we have a bunch of fractions, and one of the things you have to know, like, with, like, the restriction is that you can't divide by a negative, not that you can't divide by a negative number. You can't divide by 0. So, that's going to be a problem here. So it's going to be a problem when x is equal to 0, because for this, x cubed, 0 cubed is still equal to 0, so then that's going to be 0, and we're going to be dividing by 0. So that's a problem there. And there's going to be a problem over here and a problem over here. So we have x cannot equal to 0 because we cannot divide by 0. The denominator cannot be 0 for any of the fractions. So automatically we can eliminate choice 1 and 4 because they both have 0. And when we solve the equation, we might get that 0 is one of the solution, and it's known as an extraneous solution because it doesn't belong in the domain at all. All right, so let's go back to the equation. Okay, for this one, what I like to do is multiply everything by the least common denominator. So we look at all the denominator, and it seems like the least common denominator is just x cubed. So this way, when I multiply it, I get rid of the denominators. If it's hard for you to tell what the least common denominator is, of course, what you can do is just multiply it by like this times this times this, like the product of all the denominators. That's gonna have a little bit more work as opposed to multiplying with the least common denominator. But yeah, okay. This becomes 2 plus x squared is equal to 6. So then that means x squared is equal to 4 when I subtract 2 on both sides. So x is equal to plus or minus 2. When you take the square root, make sure you don't forget your plus or minus. All right, this is algebra now. The plus or minus is very important. So for number 8, the answer is choice 3. And we see that plus or minus 2 is not part of, neither of them are 0, so they both work. All right, what is the solution to 9 times e to the x minus 2 equals 36? Okay, they made a little mistake, by the way, guys. The x is supposed to be italicized. It's a variable. So, yeah, okay. 9 times e to the x minus 2 is equal to 36. All right, when we're kind of like solving this type of equation, it's always helpful to get this by itself, we want to get it like as small as possible, move everything over to the other side. So I'm going to divide both sides by 9, so 36 divided by 9, that's 4. And then now in order to bring it down, bring the power down, I'm going to multiply, I'm just going to take the ln of both sides. Or another way to put it is to like take the inverse of this. And the inverse of e to the power of something is ln. So whatever I do to one side, I'm going to do to the other side. So it's ln on one side and ln on the other side. And then with like logs, so ln is a logarithm, and with logs you can bring down the exponent. So I get that x minus 2 times ln of e, and we know that ln of e is just equal to 1 because ln is log base e, and log base e of e is just 1. So then this is equal to this, and then in order to get x by itself, it's pretty easy, just add 2. So we have ln of 4 plus 2. For number 9, the answer is choice 3. Okay, Reynaldo got a score of 40 on his first test. If he gets a score of 100 on every additional test, which equation could be used to determine the number of additional tests he would need to take in order to raise his test average to an 80? So we're looking for an average here. So the average, aka mean, the formula is that you take the sum of all the quantities and then you divide it by the quantity. So you take the sum of everything and then you divide it by the quantity, and that gives you the mean. So it says that he got a 40 on his first test and then 100 on every additional test. So I'm going to do 40 plus 100x divided by, now it's going to be the number. So x represents the number of additional tests, so we're going to have that here. But you also have to remember 1 plus x, because that first test, you have that first test, and he got a 40, and 100 on every additional test, and that x represents those every additional test. So you would have to do 1 plus x, and that's going to be equal to 80 because that's what he wants the average to be. So number 10, the answer is choice 1. Okay. Given f of x is equal to ln of x plus 5, what is the smallest integer of x for which f of x is defined? So for ln, we can't take the ln of a negative number. So whatever the argument is, whatever is inside here, it has to be greater than or equal to, well, it has to be greater than 0. Can't even be 0. If you go on your calculator, if you plug in, did it freeze? If you plug in ln of 0, you get that it's not defined. There's a error. It's a domain error. And you could, so yeah. So that means x is greater than -5. So smallest integer value is not going to be -5 because, well, yeah, because it has to be greater than -5. So the answer is choice 2. And if you graph it, I guess we can graph it. If we graph it ln of x plus 5, we do see that smallest value that is the smallest integer. So it's not defined at, if we look at the table, it's not defined at -5. So the smallest integer would be at -4, which is equal to 0. All right, which expression is equivalent to that bunch of stuff there when x is not 1/2? So what you can do is synthetic division. I would recommend synthetic division. So synthetic division, I would only recommend it if the denominator is a linear. So what you would do is you would first solve for this. So this would be 2x minus 1 is equal to 0, so x is equal to 1/2. And then I would set it up. So I'm going to write down the coefficients. So it's going to be 1/2. It'd be 6, 7, -9, and -1. Bring this down 6. 6 times 1/2 is 3. I'm going to add a 10. Hold up. Am I doing this wrong? Okay, wait. Okay, wait. What I do synthetic? You have to divide it. Actually, synthetic division. I mean, synthetic division would work here because we have the x minus 2. We just have to account for the 2 that we're multiplied by x minus 1/2. I'm gonna actually scratch that. Instead we're just gonna do long division. That's gonna work even if you don't have a linear term at the bottom. So we're gonna have this. When I write it, I like to make sure that like none of the terms are skipped. So it goes from like 3 to 2 and then to like 1 and then to like 0. So I like that, so I don't have to add any like space filler, like any gap fillers. I have 2x minus 1. All right, looking at this over here, what do I multiply 2x by to get 6x cubed? I will multiply by 3x squared. I will multiply 3x squared by 2x minus 1. And that would be 6x cubed minus 3x squared. And then now I'm going to subtract. 7x squared minus -3x squared, so that becomes 10x squared. And then bring this down. Why did this stop working? Hold up. Okay. When I bring this down, I get minus 9x. And then what do I multiply 2x by to get 10x squared? I multiply by positive 5x. It becomes 10x squared. And then minus 5x. And then now I'm going to subtract again. Negative 9x minus negative 5x. That's going to be negative 4x. This one. And now what I multiply 2x by to get negative 4x, I will multiply by negative 2. Negative 2, so this becomes negative 4x plus 2. And then when I take the difference, negative 1 minus 2, that's going to be negative 3. So negative 3 is my remainder. The answer is choice 4. I don't have enough space to put it here, but like I would have to add add the remainder, which is negative 3, over my divisor, the polynomial that I'm dividing by. So that's the procedure for polynomial division. It's very helpful to know. Okay, all right. A sketch of p of x is shown below where a is greater than 0 and b is greater than 0. An equation for p of x could be, all right, so here this is talking a little bit about multiplicity. So for at a or negative a, kind of like well, this is a polynomial. It says that it's p of x. You can kind of assume that's a polynomial. We know that this bounces off, so that means the multiplicity here, the multiplicity here has to be even. That means x plus a has to be an even power. So we can eliminate choice 1 and 3. And then now b, it goes straight through. So then that means the multiplicity is going to be odd. So that means the answer is choice 4. Alright, actually, wait, hold up. No, not choice 4. Sorry. I was looking at the wrong thing. It's choice 2. So I made a mistake here. if it's x minus a, then this would be, then a would be like over here. A would be over here. Because x minus a, since a is positive, it would be on the to the right of the y-axis. So I made a mistake there. I apologize. All right. We have if f of x is equal to 1/2 x cubed plus 3x squared minus 4x, and g of x is equal to 5 log base 3 of x plus 10, then which value rounded to the nearest tenth is not a solution? All right. What I would do for this one is just graph. Okay, this is glitching out. Let me refresh. Okay, so I'm gonna plug in. I'm gonna have 1/2. So I love utilizing the fraction bar. So if you see like the fraction bar, of course use that. If you need help getting into it, you can press alpha and then like the variable symbol, but you might not have that. If you have the older calculator, you press alpha and then you will press y equals for f1. That's one of the function menu, and the first thing is the fraction bar. So 1/2 x cubed and then plus 3x squared minus 4x. So that's gonna be y1, my first one. Oops, I cleared it by accident. 1/2 x cubed plus 3x squared minus 4x. Okay, I'm gonna press down. And it's gonna be 5. So for log, you're gonna go to math and then you're gonna go to the bottom. So I would just press up because it just skips you to the bottom. And then you see log base. So we have log base, the base is 3, and then whatever's inside is x plus 10. Okay, now graph it. We're gonna adjust the window a little bit because I want to see whatever's on top there. I'm gonna go to window. Let me just increase the y to maybe like 50. Okay, seems perfect here. So let's see the points of intersection. So we're gonna go to second calc, and then you want to go down to intersect, and then you want to do, okay, well, you just kind of like go to it and then you just keep spamming yes. So one of the intersection is -6.9. I'm gonna eliminate choice 1. Second calc, I'm gonna go to intersect again, and then I just like to scroll over to the point of intersection and just keep spamming it. And I get that another intersection is -1.36, so that's choice 2. We're gonna eliminate that. And then once more, and we should be able to get the answer. Oopsies, huge jump there. Okay. All right, it's 2.2. So the answer is choice 4. Okay, all right. F of x is shown, which graph represents f of x plus 3. So when kind of like when you're adding like to like x directly, this represents a horizontal shift, a horizontal translation. So x plus 3. So when it's horizontal, it's a little bit counterintuitive. X plus 3 is not going to move to the right. It's going to move to the left. So this is going to be left translation by 3 units. 3 units. So this one is going to be choice 15 is choice 4. Because that's the only one we can kind of like see an asymptote here at x is equal to 0, and it's the only one where the asymptote is moved to the left by 3 units. All right. What is one solution to the system of equations shown below? So if you want to graph this, it's going to be a little bit harder because you have to, because here is not y equals. You have to get y by itself, and you would get like 2 equations. I don't recommend doing that. What I would do is just plug it in and solve. So we do get y equals, so that's one of the variables. I would use substitution. So we have x squared plus y squared is equal to 20, right? I know what y is equal to. Y is equal to x minus 6. I'm going to plug that into the first equation. Square it, and I get that. Okay. By the way, for your solution should be, usually it's like a point. Because we have a circle and a line, when they intersect, it's going to be point. So 1 and 3 kind of does not really make sense because they're not points in the context of this question. This is a circle and this is a line. And circle and line could either intersect at one place, 2 place, or no place. So yeah. Okay, what I'm going to do is I'm going to expand this. This becomes x squared minus 12x plus 36. 20, and then this becomes 2x squared minus 12x plus 16 when I subtract 20, and that's equal to 0. I want to, when I'm solving for quadratics, I always want it to be equal to 0. Okay, to make it easier, I'm going to divide everything by 2. So I get x squared minus 6x plus 8 is equal to 0, and now I'm going to factor. I want to find two numbers that multiply to 8 and add up to -6. I'm thinking of 2 and 4. Since they add up to a negative number, but they multiply to a positive number, both of them take the negative sign. Oops. So then this becomes x minus 2 times x minus 4, and that's equal to 0. So x is equal to 2, and then x is equal to 4. Okay, so in this case, we're just left with the 4s. So I'm just going to plug in 4 into the second equation. Y is equal to x minus 6. Y is equal to 4 minus 6, which is equal to -2. So for 16, the answer is choice 2. All right. At a high school, 10th grade students were recently asked if they walk to school and if they eat breakfast. The results are summarized in the table below. So we have a two-way table here. What's the probability that a random selected 10th grader from the school walks to school or eats breakfast? So walks to school. So here, walks to school or eats breakfast. So it's all of these here. So we have 7 plus 53 plus 10. And now over the total. And it doesn't give us a total, so we kind of have to add that up. 53 plus 10 plus 30. So I'm just going to do that on the calculator real quick. So 7 plus 53 plus 10 all over 7 plus 53 plus 10 plus 30. And I get 7 over 10. And that's equal to 0.7. So it's 17. The answer is choice 2. So keyword here is or. So we would have to add up like all of these. And if you pick just 7, that's and. That's if they walk to school and eats breakfast. In this case, we have or. So we have to do 7 plus 53 plus 10. Okay. A vehicle's depreciation rate is 9.2% per year. If a vehicle costs 34,150, which recursive formula. Here it says recursive formula. So recursive formula means that we are going to be using the previous term to help us. So we can eliminate 1 and 2. These two, they're explicit, and it doesn't like depend on the previous term. After n years, it's purchased. Okay, so we're gonna do a sub 0. That's gonna be my starting value, and for both of them is 34,150. So that's correct. So then now the difference is that whether I'm multiplying 1.092 or 0.908 to the previous term. In this case, it says that the depreciation rate, that means the value is decreasing. So I'm going to multiply by a number that's less than 1 for it to decrease. So for 18, the answer is choice 4 because 0.908, that's less than 1. So every time you multiply the previous value by that number, it's going to decrease. Okay, when factor completely, the equation, the expression is equivalent to. Okay, so this out, like if it's hard for you to like visualize this, I'm gonna set a is equal to 3x minus 1. So I can rewrite this as a squared minus 5a plus 6. And then now we have a trinomial here, which is pretty easy to factor. I want to find two numbers that multiply to 6 and add up to -5. So I have 2 and 3, and they're both negative. Yeah. Okay, so then this becomes a minus 2 and then a minus 3. And we said that a is equal to 3x minus 1, so I can just plug that back in. So this 3x minus 1 minus 2 times 3x minus 1 minus 3. So then that's equal to 3x minus 3 times 3x minus 4. And then, yeah. So for number 19, the answer is choice. It says factor completely. One more thing we can do, we can factor out the GCF for the first one, which is 3. So make sure you factor out the GCF. That's the part where I almost forgot. Make sure you have that. All right. Given e of t is equal to 26 times 2 to the power of t over 20 represents the mass in grams of a substance after t minutes in a laboratory. Which statement of this statement must be true? All right. So since we're multiplying by 2, that means it's doubling within a period of time, and the period of time is given by t over 20. That kind of like signifies like that's where we would look to figure out like the period of time. So here it says, well, basically if you translate it, after every 20, I think it's measured in days. Oh no, minutes. After every 20 minutes, the sample doubles. So that's how you would translate it. So 2, this means that it's double. And then the divided by 20 means every 20. In this case, the unit is minutes. So what is true? So initial mass of these substances is 26 grams. That is indeed true because the number that you have in front, that's almost always going to be the initial value. So that's true. The substance doubles every 20 days. So that's incorrect because we said that it's every 20 minutes. So the days is wrong. And the substance after 3 hours is approximately 90 grams, 29 grams. Well, I mean, we can kind of assume that's false because it's more than, like, 3 hours is more than 20 minutes, and after 20 minutes it's expected to double. What you can do is just plug it in. All right, so 3 hours is 180 minutes, so 180 over 20. This is equal to 26 times 2 to the power of 180 divided by 20, and it is a fairly large number, so, and that's not equal to 29. So the answer is choice 1 only. All right, for x is greater than 0, which expression is equivalent to that over there? Okay, so it seems like we want rational exponents. So let's look at this over here. 3 cube root of 9x squared times square root of 9x. So this is gonna just make it like this. Hope you see this. So then this is 9 to the 1/3 times x to the 2/3 times x. This will be 1/2. My bad. 1/2 times x to the 1/2. And then we kind of like combine things now. So since we have the same base and we multiply, we would just add up the exponent. 1/3 plus 1/2 is 1/3 plus 1/2. That's equal to 5/6. And then now we will add the exponents here, so that would be 7/6. So then the answer is choice 4. So when you have that over there, it's just multiplication, and we can kind of like distribute the power, if that makes any sense. So yeah. Okay. The number of people who have read an article grows exponentially throughout the day and can be modeled by the function. That's the function. Where t represents the number of minutes since the article has been posted. Which equation best represents the number of people who have read articles in terms of the rate per second? Okay. All right. So for 22, so my t now becomes second, and I want to convert it into okay, I'm gonna eliminate. We can eliminate t is the number of minutes. Okay, we're gonna eliminate 1 and 3 because here we have t divided by 60. So t is in terms of minutes. If we want like the growth per second. So in order to convert minutes to seconds, we will multiply by 60 instead. So whether it's choice 2 or 4, I mean, we can kind of see what it is. It's choice 2. It has to like decrease. So how do we find that rate? So what you can do is, so since we want it to be per second, so I want to see what it multiply in 1 second, right? So again, t is in terms of minute. So ignoring the 2, what if we plug in 1 over 60 as t? So that's the second, right? That's 1 second. You would get that it's about 1.000162551. That gives us the growth rate every minute. Not every minute, every second. Because I plug in 1 over 60. 1/60th of a minute, that's equal to 1 second. And that's how I get the growth rate. And I would just kind of just remember this. All right. Which equation represents a parabola with a focus of 2, -5 and a directrix of y equals 3? All right, so when we have, okay. This is a kind of like an equation you want to, like, this kind of like a form that you want to remember. So you have x minus h squared is equal to 1 over 4p times y minus k. Okay, I like to visualize this. So directrix is at y is equal to 3, so that's y equals 3. It has a focus of 2, -5. So this, let's make this 2 and then -5. So that's gonna be my focus. My focus is here. So my parabola is gonna look something like this. So the vertex is gonna be halfway between the directrix and the focus. It's gonna be like right is going to be on that line. So halfway mark is going to be -1, because 3 plus -5 is -2, and -2 divided by 2 is -1. So my vertex is going to be, so HK is my vertex, and that's going to be at, so the x stays the same, 2 comma -1. So this one should be x minus 2 squared is equal to 1 over 4 p times y plus 1. And is there anything I can eliminate? I can eliminate choice 3. All right. And now how do you find that the p? So the p is the distance from either the directrix to the vertex, or from the vertex to the focus. And you can see that this distance over here, it's just 4. So my p is equal to 4. So, oh, sorry, this is not supposed to be 1 over 4. It's just 4p. Oh, I'm so sorry. 1 over 4p is 1 over 4p. That's if you have, it's in the other form, and like when you have like the y equals form. I apologize for that. Okay. Here my p is gonna be 4, so it's gonna be 16. But you have to be careful. Is it? Oh, actually, I can eliminate. I can eliminate choice 1. Can I eliminate choice 1? Let me double check my notes. Okay, wait. Why is that -1? Oh, wait, no, I'm not eliminating choice 1. I'm eliminating choice 2. Okay. All right. So again, my p is at 4. So then my number in front. Well, I'm gonna actually put this as absolute value of p. That's 4. That should be 16, but we have to be careful. There's a sign. Is it positive or negative? So with my really, really bad diagram, we can see that the parabola opens downwards. So then that means it has to be negative. So in this case, the answer would be choice 1. Okay, which graph shows a 4th degree polynomial? So 4th degree, the power is even. So that means the end behavior is going to point in the same direction. So we can eliminate choice 3. Choice 3, the end behavior point in different directions. So that's wrong. With exactly 2 imaginary roots. So if there's 2 imaginary roots, that means we have 2 real roots. So this is like the fundamental theorem of algebra. The number of roots, so like the number of roots, the total number of roots matches whether like it's the total number of roots, whether it's imaginary or real. It depends on the power, the highest power, the degree of the polynomial. In this case is 4. So we have 2 imaginary roots. That means we must have 2 real roots. And imaginary roots always come in a pair. So you can't have just one imaginary root. You can either have 2 imaginary roots, 4, 6, etc. So here we have 2 imaginaries. That means we have 2 real roots. So that means it should intersect with the x-axis at 2 points. And we see that only choice 1 does that. So the answer is choice 1. Choice 2, it intersects at 4 points. So all of the roots are real. And so that means they don't have any imaginary roots. So that's wrong. And 4, there's 0. There's 0 intersection with the x-axis. So that means all the roots are imaginary. But the problem said that there are only 2 imaginary roots. So that's incorrect. The answer is choice 1. All right, that's it for today. Hope this helps.